We're doing Ramya Shri, please switch on your camera. Navina, Ramya Shri, Arush. So we were doing vertical circular motion, right? It was left. We did something in work energy and power. So did you guys practice some questions on work energy and power? Datta, Navina. Datta, you practice some questions in work energy and power.
Right, right.
You tried? How
I
many
tried
questions?
those examples in HC.
HCV. Abhi HCV is not
Right,
completed yet?
right, right.
Not done yet?
No,
Not yet started with exercises?
no.
Nahin?
I'm
Okay.
done objectives.
Okay. Navina, how many questions you have done in work energy and power?
So some 20 to 25 questions. Sir.
You
20
did
to
20, 25 questions. You have doubts?
no, sir.
Sure. You are able to understand the chapter? Okay. Ramya Shri, what about you?
Sir, I did one question paper, sir, in work energy power.
You are?
I did one question paper, sir.
Okay.
Practice test question paper, sir.
Nee,
It
nee,
consists of 45 questions.
but
Simple questions.
nee, nee, but you were you able to did you complete HCV or did you complete any other textbook or any other exercises from of its work energy and power?
Yes, sir.
From where did you do?
Sir, Akash Method have did, sir. Questions practice, sir. Test booklet.
Okay.
Questions.
Okay. But you didn't complete HCV? Didn't do
Sir,
problems from HCV?
sir, only solved examples I did, sir.
Only solved examples.
Yes, sir.
Okay. Okay. आदित्य क्या हाल है बेटा?
Yes, sir. Good, sir.
गुड. कितने क्वेश्चन हो गए अभी HCV से?
Sir, 4, 5 questions only.
बस. क्यों ऐसा?
Sir, there is a test in my school.
सॉरी.
Sir, there is a test in my school.
टेस्ट. तुम 12th में हो क्या?
Yes, sir.
ओ. शिव कल्याण शेट्टी जी, कैसे हैं
Yes,
आप?
ठीक.
और बड़े दिनों बाद शिव.
Yes.
ठीक है. चलो
सर,
लेट्स स्टार्ट.
सर
हाँ
अभी
बोल.
कौन सा चैप्टर चल रहा है, मतलब
यहाँ पे
आइडिया है
वर्क
भाई?
एनर्जी चल रहा है बेटा. है ना.
ठीक,
आज आज हम लोग वर्टिकल सर्कुलर मोशन कंप्लीट करेंगे उसका. ठीक है.
ठीक.
और फिर जो है तुम्हारा फिर आगे बढ़ेंगे. ठीक है. तुम्हारा वो मेरे से एक बार तुम क्लास के बाद बात करो ना. तुम
ठीक.
11 बजे सो जाते हो क्या?
हाँ. हाँ.
कल सुबह बात करेगा मेरे से. कॉल करना मेरे को सुबह जब भी तू
यस.
फ्री होगा तब.
ठीक.
ठीक है.
हाँ.
चल. सो प्लीज, डिड यू गाइस कंप्लीट दिस वर्टिकल सर्कुलर मोशन वाला पार्ट? If you have not completed it, please complete it. Do it. Write it in 2 to 3 minutes. Complete it, and then we will move ahead with solving problems on vertical circular motion. We will learn this today. Once you are done writing, type done in the comment window. So Ramya Shri is done. Rest of you, please type done in the comment window if you are done writing this, huh? Chalo. So let's solve questions on vertical circular motion, okay? Did we do any type of work done by tension and all? Have you seen work done by tension or work done by normal reaction in a circular path? Have we done that type of question? चलो कोई बात नहीं किया लगता है तो तभी तुम नहीं बोल रहे हो
No,
ना.
sir.
Okay. So see, this is a pendulum, okay, and it is tied at this point, and about its point of suspension, it is given a velocity u here, right? And it will start moving in a circular path. All of you, please pay attention. So first of all, what I want all of you to be very specific is, see these points, important positions, right? Bottommost point, topmost points, and point where either the string becomes slack or the object loses contact with the track. So these are important points for all of us. Okay. So here, when this pendulum is moving in a circular path, so let's draw some different positions for this pendulum. This is one, this is another position, this is another position. Okay. And let's say this is another position. Okay. Now, obviously, this pendulum has to reach the topmost point for this object, for this bob to complete the circular path. Yes or no, all of you?
Yes, sir.
Yes.
This pendulum has to reach the topmost point. Let's call this point as A and this point as B. So this bob has to reach the topmost point for this bob to complete the circular path, right? Now tell me, at the topmost point, whether the velocity of the bob should be equal to 0 or should not be equal to 0? All of you? Whether the velocity of bob is equal to 0 or not equal to 0 at the topmost point. All of you, tell me please. What can you say about the velocity of the particle or the bob at the topmost point? All of you. This is question to all of you. Please type your responses or switch on your camera and speak. Sarvesh, what is your suggestion? What is your answer for this?
Hello.
Sorry?
Sir, sir, thinking.
Thinking. Okay. Think.
Sir, I think it should not completely be equal to 0, almost 0.
Okay. What will happen, Preetham, if it is equal to 0?
So then the string will sag, it will come down.
Okay, very good. So at the topmost point, all of you see at the topmost point, if you imagine yourself tied to this rope, you imagine yourself tied to this rope, right? So draw your own. So you are tied to this rope. What will happen at the topmost point if the velocity becomes 0? Tell me. You will fall from here, yes or no?
Will fall.
Yes, sir.
Yes.
हाँ, you will fall from here, है ना? So that is why you can say that सीधे यहाँ से यहाँ जाओगे, है ना? That is why you can say that there should be some velocity of this object. So velocity v is not equal to 0 at the topmost point. All of you understood this?
Yes.
These are the two most important points, bottommost point and the topmost point, right? In case of vertical circular motion. Then the third most important point is where the string slacks or the object loses contact. Okay. Now, identify the forces acting on this object. Identify the forces acting on this object. So mg is always acting downwards. Yes or no? So mg is a constant force. बच्चों समझ आ रहा है बेटा? All of you?
Yes, sir.
And
Yes, sir.
and tension is a force which is acting towards the center. See, tension is a force which is acting towards the center. Yes or no? Now at every point, this tension will start changing. Let's say this is T0, this is T1, this is T2. Yes or no? Tell me, tension will change
sir.
or not?
Yes, sir.
Yes, sir.
Subhya, can you please tell me why it is changing, beta? Can you please tell why it is changing?
Sir, I
Sir,
guess
the
it
tension will be
change as it
maximum
would
at the bottommost
It would
point.
give it century.
That एक मिनट तुभ्या तुम बोल रही थी बेटा कुछ एक मिनट स्तुति हाँ
So the tension will be maximum at the bottommost point.
so it is maximum at the bottommost point but how you can say it is changing it's very simple velocity is changing at every point because there is some gain in kinetic energy there is some gain in potential energy right
Yes, sir.
है ना so since there is gain in potential energy so decrease in kinetic energy is there and tension is related to what the component of mg along this direction along the radial direction
Yes, sir.
component of mg along radial direction so say this angle is say theta so this is mg cos of theta let's say it is theta 1 so t1 minus mg cos theta 1 all of you see this why it is varying t1 minus mg cos theta 1 is equal to mv1 square over l this is playing the role of centripetal force yes or no all of you this is playing the role of centripetal force right so t1 minus mg cos theta 1 is equal to mv1 square by l so t1 is dependent on what t1 is dependent on theta and t1 is dependent on velocity so that's why tension is a variable force all of you understood this why tension is a variable force
Yes, sir.
Sure.
Yes,
very
sir.
good तरुशिखा को समझ आया कि नहीं आया
यस सर आ गया
शाबाश बेटा आशीष लमानी शितिका शितिका को समझ आ रहा है
So, yes, sir.
ठीक है बेटी और कौन है इधर स्तुति
Yes, sir.
ठीक है Ramya Shri you understood
Yes, sir.
okay so now we have two forces here one is variable the other one is constant so all of you tell me how to find work done by a variable force how to find work done by a variable force चलो कौन बता रहा है मुझे एक मिनट हाँ लेट मी श्रुतिका बताओगे बेटा हाउ टू फाइंड वर्क डन बाय अ वेरिएबल फोर्स श्रुतिका नहीं बताओगी चलो एक सेकेंड रुको. Navina, will you tell how to find work done by a variable force?
Sir, by integration,
No, first step. What is the first step, beta?
find the work done by the force for a small displacement.
Very good. So where should we do the small displacement here? The displacement is always along the tangential direction. Yes or no?
Yes, sir.
So let's do a small displacement along the tangential direction. So the pendulum is, the bob is traveling from this point to this point, right? I have drawn, this is the point. ठीक है? All of you understood? This is the small displacement. Please pay attention. This is the small displacement, right? ds vector. Now tension is acting towards the center. T1 is a variable force. So tension is a variable force, right? So what is angle between tension and displacement, all of you?
Perpendicular.
90 degrees.
90 degrees is the angle. Sarvesh, you understood, beta?
Yes, sir.
Okay. So Sarvesh, tell me what is work done by tension here? It's T dot. Sorry. This is 90 degrees, right? The angle between them is 90. So Sarvesh, this is T ds cos 90. So what is the work done by the tension, beta?
Sir,
What is cos 90, Sarvesh?
sir, cos 90.
Cos 0?
Sir, what?
What is cos 90?
The cos 0.
Yes, cos 90 is 0. So what will this value be? T ds into 0, right? So this is 0. So dwt is 0. So what is work done by tension now?
0.
Integration of 0 is 0. Got it, all of you? Hello.
Yes, sir.
Yes, sir.
So this is how we prove that. This is how we prove that work done by tension is 0, right? Now, work done by mg. How to find work done by a constant force? So work done by a constant force is we simply do F dot S vector, right? Between initial and final positions. So our initial and final positions are A and B, right? So what is the displacement of this bob from A to B? This is the displacement. If the length of the pendulum is L, what is the length of this string? Sorry,
2L.
what is the displacement? Yes.
Sir,
So
12.
it is mg minus j cap. Mg is acting downwards, right? Mg is acting downwards. So mg minus j cap dot 2L plus j cap. I hope all of you understood this. Yes or no?
Yes, sir.
Yes, sir.
Ramya, Shri, Sanvi, Sarvesh, Pavni, Preetam.
Yes, sir.
Yes.
sir.
Yes, sir.
Yes.
Okay. So we have, this is minus mg into 2L. This is work done by mg. So there were only two forces which were acting here, right? One was tension, the other one was mg. One was variable, the other one was constant. So we found the net work done. Now, what to do with this force work done? What should we do with this work done? Total net work done is equal to change in kinetic energy. Remember or not? Hello.
Yes, sir.
Work
Yes, sir.
energy theorem. We are
sir.
applying work energy theorem, right? So this is half mv square minus half mu square. This is the first equation using work energy theorem, right? We are using work energy theorem. Okay.
Yes, sir.
Now, second one is the concept of circular motion. So at the topmost point, why we are applying the concept of circular motion at the topmost point only is because this is a critical point. After this, it has to move ahead, right? So at the topmost point, what is the velocity? How can you write the circular motion equations? Net force towards the center is what? Mg is acting downwards. Tension is acting downwards, right?
Yes, sir.
So net force towards the center is how much? Mg plus T. And that is what? It's mv square by L. I hope all of you understood this.
Yes, sir.
Datta, understood or not?
Yes.
So we have these two equations. This is equation number 1. This is equation number 1. And this is equation number 2. Now, what was our agenda? Our objective was to find minimum value of u, for which the particle completes the circular path, right? We have used all the steps here. Yes or no? Please check. We have used all the steps, right?
Yes, sir.
आरुष को समझ आ रहा है कि नहीं?
हाँ सर.
ठीक है. So from here, in this case, let's see what is u square. U square is v square plus 4mgl. This is u square is v square plus 4mgl. And from here, what is v square? V square is gl plus tl by m. Now pay attention. See, in either of the cases, here in this u equation, what is happening here is v is minimum, sorry, u is minimum. एक मिनट है, थोड़ी सी जगह बना रहा हूं मैं यहाँ. In this case, u is minimum when v is minimum. Yes or no? Because m, g and l are constant.
Yes.
U is minimum when v is minimum. Right? And
Yes, sir.
this is in this case. In this, from this equation, right? And from here, we can easily say that v is minimum when t is minimum. Yes or no?
Yes, sir.
Yes, sir.
So what is t minimum? All of you. For you, what is minimum value of t? Minimum value of t in any case is 0, because that
0.
is the case when the string slacks, right? T cannot be
sir.
negative. T cannot be negative.
Yes, sir.
So minimum value of t is 0. Since t minimum is 0, therefore v square is equal to what? GL. And here, since v square is equal to GL, so u square is equal to what? 5GL. So from here we get u as root of 5GL. This is the minimum value of u. This is the minimum value of u for which the particle or the bob completes its circular path. I hope all of you understood the concept. Yes or no?
Yes, sir.
Please copy it. If you have any doubts, please ask.
Yeah. Sir, you have written u square is equal to v square plus 4 mgl. Shouldn't it be
4GL, 4GL.
Yes.
Once you're done, just type done in the comment window, huh? See, this is very important concept. At least one question is asked from here, huh? All of you, please, as soon as you are completed, if you have completed it, type done in the comment window, huh? We will do more questions in this. Chalo. Let's do a question based on circular tracks also. Okay. So this is a circular track. This is a circular track. A small object is kept at the topmost point of this track. Right? All of you, please pay attention. A small object is kept at the topmost point of this track. Now the track is frictionless and the object is kept outside the track, right? So there is no friction here. Now what happens is this object starts moving with a small, the object starts sliding on the circular track, right? So initial velocity is 0. It starts at 0 velocity. Now what will happen is it reaches this point. Okay. You have to find at what point on this track, the object loses, the block loses the contact with the track. ठीक है बेटा? So let's say at this point on the track, the object loses contact. All of you, please pay attention, huh? What will you do? Again, identify the forces. First step is identify the forces. See, mg downwards, normal reaction n upwards. Right? Again, which one of these two forces is a variable force? Which one of these two forces is a variable force? Yes, normal reaction is a variable force. Very good. Because mg remains constant, velocity is changing. So normal reaction is a variable force, right? So let's say the normal reaction here is n dash. Now, let's say the angle traveled by the block is theta. So identify the points first, name the points. This is point A, this is point B. This is radius r. And this is r cos theta. Right. This is r cos theta. All of you, you are able to understand it or not? Figure it out or not? Hello.
Yes, sir.
Yes, sir.
By how much height this object has fallen? What is the height by which this object has fallen? See, this is the height, right?
R
This
minus
height is r times 1 minus cos theta. R minus r cos theta. Sarvesh, Pavni, Tubhya, Vaidehi, Tuti, Rangila. Understood or not?
Yes, sir.
Yes, sir.
Sarvesh? Okay. So now let's find the work done by mg here. So mg is acting downwards. Displacement is also downwards. Between A and B, what is the displacement? R times 1 minus cos theta, right? So work done by mg here is mg minus j cap dot r times 1 minus cos theta minus j cap. And this is mgr times 1 minus cos of theta. I hope all of you understood it. Yes or no?
Yes, sir.
Yes, sir.
Now, what about work done by normal reaction? Since it's a variable force, so we will find work done for a small displacement. All of you see here, the displacement is along the tangential direction, right? So since the displacement is along tangential direction, the angle between normal reaction and displacement is what? 0 degrees? Sorry, 90 degrees?
90 degrees.
So this is the displacement here. I'll write again. This is the displacement here, right? And so R and displacement ds vector. So n dot ds vector, what is it? Hello? What is n dot ds vector? 0, right? It is n ds cos of 90. The angle between them is 90 degrees. So work done by normal reaction is again 0. Any challenges till this point? Any one of you is facing any challenge, any doubts? Please ask.
No, sir.
Shitika, Shitija, Stuti, Pavni, Rangila, Navina, Datta, Arush, आरुष
हाँ सर.
समझ आ रहा है बेटा?
हाँ.
तो नेटवर्क डन क्या हुआ यहाँ पर? mg प्लस नॉर्मल रिएक्शन. आरुष चल बता, तू मुझे बता बेटा, व्हाट इज द चेंज इन काइनेटिक एनर्जी हियर? Between A and B, what is the change in kinetic energy, Arush? फाइनल काइनेटिक एनर्जी क्या है बेटा इसकी? हाफ mv स्क्वायर है ना? इनिशियल क्या है? 0 है. तो चेंज क्या हुआ? यही हुआ ना? So it is mgr times the change in the work energy theorem says that mgr times 1 minus cos theta is equal to half mv square. Right. Now go with the important points. What was the important point? Bottom and topmost point. So there is no bottommost point, but there is a point where at which the object is losing contact, right? There is a point at which the object is losing contact, and this is the point. Yes or no?
Yes, sir. Yes, sir.
है ना? So here, what is the net force towards the center? This angle is theta. It is mg cos theta. So net force towards the center is mg cos theta minus n dash is equal to mv square by r. Since object loses contact with the ground, with the track, since object loses contact, therefore n dash is equal to 0. So from here we get it's mg cos theta is equal to mv square by r, or we get v square as gr cos of theta. Got it? बोलो भाई बच्चों, समझ आ रहा है नहीं आ रहा है? हेलो.
Yes, sir.
So substitute the values of gr cos theta here. So it is mgr times 1 minus cos theta is equal to mgr times cos theta by 2. This cancels out. From here we get cos theta is 2 by 3, or theta is equal to cos inverse of 2 by 3. Sarvesh, you understood or not?
Yes, sir.
Any doubts?
No, sir.
Chalo.
Sir, instead of using work energy theorem, we can directly use conservation of mechanical energy, right?
Obviously we can use, no issue. Same equations will be there.
Yes.
I just wanted to show them work done by normal reaction. That's why I did.
Yes.
Please copy it quickly, all of you. Done, all of you?
Yes, sir.
If you are done, type done in the comment window, huh? Good. So let's do some questions from HCV based on these concepts. All of you draw this figure. 55th ka figure hai ye. This is the question, right? All of you draw the figure and then I'll write the question for you. Okay, what I'll do is now I'll draw the figure for you and you can then solve it. Just a second. Okay, this circle is of radius r. This circle is of radius r. Right? Now I will write the question. So figure shows a smooth track, a part of which is a circle of radius r. A block of mass m is pushed against a spring of spring constant k fixed at the left end. Okay. And is then released. ये क्या किया मैंने? अच्छा, एक सेकेंड है बेटा. Now it is fixed. ठीक है. Please try doing this question. It says figure shows a smooth block. This is the block, right? A part of which is a circle of radius r. So this is a circle of radius r. A block of mass m is pushed against a spring of a spring constant K. So this is spring constant K fixed at the left end. So it is compressed towards the left end, right? So let's say the initial compression in the spring is X naught, right? It is then released. And what will happen? This ball will start traveling. This block will start traveling this circular track. So at the topmost point, find the initial compression of the spring so that the block presses the track with a force mg when it reaches point P. So this is the point P where the radius of the track is horizontal. So at this point, the block is pressing the track with a force equal to mg. So what is the force exerted by the track on the block at this instant? It will be mg. Yes or no, all of you? Hello?
Yes, yes, sir.
Yes, sir.
समझ आ रहा है बेटा नहीं आ रहा है? So
Yes,
now
sir.
this is what you need to find. वो पूछ रहा है what is the initial compression? What is the value of x naught? All of you try. So our important points are this point A and this point P. These are our important points, right? Find the work done or conserve the energy. Do whatever you feel like doing. There will be some velocity at this point, right? There will be some velocity at this point. You need to think accordingly what is happening here. Okay? Conserve energy between A and P. Conserve energy between A and P. What is the initial energy of the spring block system? All of you tell me. What is the initial compression in the spring? X naught. So what is spring potential energy here?
Kx square.
Half K X naught square. I hope all of you understood this. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. And this is equal to what? Change in kinetic energy. So it's half mv square plus it's mgr also. Rise in gravitational potential energy. Yes or no? It is
Yes,
rising
sir.
to a height r.
Yes, sir.
All of you understood this?
Yes, sir.
Yes, sir.
Now normal reaction. Now normal reaction exerted by the track on the block is N, right? So N is equal to what? mv square by r. Yes or no?
Yes.
And what is this N? N is given as mg. See? It says that it is pressing the track with mg. So N is equal to mg here. Given hai. This is given. I hope all of you understood this. Yes or no?
Yes.
So
Yes,
V
sir.
square is equal to GR. Substitute the value there. You get half kx naught square is equal to 3 by 2 mgr. Or x naught is equal to 3 mgr by k. Understood how to solve these type of problems now? All of you.
Yes, sir. Yes, sir.
Yes.
Simple है देखो, conservation of energy, circular motion के equations, that's it, nothing more than that, right? Copy it quickly.
Yes.
Next class, that is next. बहुत दूर हो जाएगा ये. Saturday बहुत दूर हो जाएगा. Copy it quickly. I'll give you some questions to solve from this chapter, right? I'll tick mark it for you. Please do it. Those of you who are preparing for engineering and IIT, they should solve all the problems. Not NEET students, I'll give you some questions to solve. Okay.
Yes.
Okay, sir.
Please solve these questions, huh? All of you. 64, 62, 60, 59 we have done. 61. So 60, 61, 62, 64. 51 is what you, all of you should do it. 56. NEET student should solve these questions. 43, 47, 48. 45. बाकी तो ये सब तो करो, इसमें कुछ है भी नहीं, ठीक है? Don't do all the questions from here, but do all these. ये तो करना ही है, कहीं से भी. I hope all of you understood today's session. Yes or no?
Yes, sir.
Yes, sir.
Anything which was not clear to you, we can discuss it right now also. Please ask if you have any challenge.
Sir,
हाँ बेटा बोलना.
sir, I had a few doubts.
वो भेजा था बेटा तूने मुझे, मैं तबीयत ही मेरी खराब हो गई. कल क्या कर रही तू?
Sir, कल classes है.
शाम को?
Sir, सुबह है, शाम को नहीं.
शाम को कितने बजे फ्री हो जाओगी?
Sir, 5 बजे.
7 o'clock, 7:30 मिले? 7:30.
Okay, sir.
पक्का?
सर, मैंने भी मेरा
Yes.
डाउट्स भेजा था सर.
तू भी आ जा कल.
हाँ.
ठीक है.
7:30 PM सर.
चलो बाय.
बाय.
Thank you, sir. Bye.
Thank you,
थैंक
sir.
यू.
Thank you, sir.
Thank you, sir. Bye, sir.
बाय बेटा बाय. टेक केयर.